What if I told you that teleportation might actually be possible? We're talking about quantum teleportation, which is a type of science that's getting us closer to actual teleportation. So what is the science behind this and how does it work? Alright, so let's get into it. Quantum teleportation isn't the beam me up Scotty teleportation that you've seen in sci-fi movies, but it's still something incredibly exciting. In quantum teleportation, scientists don't move physical matter like people or objects from one place to another. Instead, they move information about the quantum state of a particle. It's the science of transferring information between two entangled particles, no matter how far apart they are. This process relies on something called quantum entanglement, where two particles become linked in such a way that the state of one particle instantly affects the state of the other, even if they're light years apart. Superposition. Here's where things get even cooler. Another key player in this process is superposition, the ability of a quantum particle to exist in multiple states at once. For example, an electron can be in a state where it's both spinning up and spinning down until we observe it. This weird property is what makes quantum teleportation so powerful and what almost resembles the teleportation that you see in movies. In quantum teleportation, the quantum state of a particle in one location is entangled with another particle in a different location. The magic happens when you measure the state of the first particle, and that measurement determines the state of the second particle, instantaneously across vast distances. This is known as the quantum state transfer. So even when we're not teleporting a person into space, we're transferring quantum information, which is a crucial step towards understanding how to move larger things like matter. Now, superposition is the true meat behind quantum teleportation because in a quantum computer, for example, bits of information don't just exist as ones or zeros. Thanks to superposition, they exist as both at the same time. And if we could harvest this kind of behavior for a larger system, who knows? We could eventually be looking at teleporting objects, perhaps even people, by transferring their quantum state elsewhere, reassembling them elsewhere. Essentially, what scientists are doing now is transferring the quantum state of one particle to another over great distances without physically moving the particles themselves. But superposition is what makes this possible. It's almost like you're moving the identity of a particle rather than the particle itself. Right now, scientists are able to teleport the information of quantum bits or qubits across small distances. We've even seen teleportation successfully demonstrated with photons over hundreds of kilometers. But scaling this up to, for example, trying to do that with a human body is a huge hurdle. Just think about how much more complex it would be to teleport something as large and intricate as a person. We're talking about transferring the quantum state of every single atom in your body and then reconstructing it exactly the same way on the other side. That is a massive amount of information. So while we may not be teleporting humans just yet, the breakthroughs in quantum information transfer could one day lead to advances in quantum computing, secure communications, and even space travel. So for now, quantum teleportation is basically just a stepping stone. So is teleportation possible? Not really, but thanks to superposition and quantum entanglement, we're getting very, very close.